Well, hello everyone. We are going to do today the last part of chapter 6 that you need to cover for this week. It's quite a short section. Going to look at adding and subtracting rational expressions. So before we deal with rational expressions, let's talk about how do you just add fractions together. Now, if everything is numerical as they are here, as long as they share a common denominator, you can simply add the numerators together. And in this case, 8 over 4, which would simplify down to 2. So the key to adding and or subtracting rational expressions is to make sure that they both fractions, if there's two, share a common denominator. And if they do, then you can add the numerators together. So if we look at an example of a question like that, suppose I wanted to add those two fractions together. Since they share a common denominator, I can simply just add the two together. And that may well be the answer, but we should always be aware that in many situations, you should be able to, at least in a lot of them, simplify. So I'll pull out 3 as a common factor. And I'm going to factor x squared minus 1. In this particular case, I do get some cancelling. And so the final answer is 3 over x minus 1. Now you might get an example like this, for instance. Again, we share a common denominator. And so you can simply, in this case, add all the terms on the numerator together. And if I collect like terms, 1x squared plus 1x squared gets me 2x squared. 4x take away 7 leaves me with negative 3x, and plus 2 plus 1 gets me 3. And in this case, I could try and factor it, but this one doesn't factor, so I'm pretty much finished. So sometimes you can factor and cancel and simplify your fraction. Sometimes you cannot. Well, how about subtraction? How would that work? Well, if I take the exact same question, or the exact same two fractions as we had in the previous one, but instead of adding, I subtract them, then we have to be much more careful. This subtraction is subtracting all of those terms, so that when we combine the top together, we're going to have x squared plus 4x plus 2, but take away all of them. So I'm distributing that negative. And this time, when we collect like terms, we get quite a different result. These two cancel each other out. 4x add 7x gets me 11x, and 2 take away 1 gets me 1, and I'm pretty sure I can't do any more. And so that question essentially is now over. Show you one of your homework questions, at least a version of it. So 3x over 3x squared, add 16x, take away 12, subtract 2 over 3x squared plus 16x, take away 12. Now, they share a common denominator. And we have 3x take away 2. Now, I may be able to simplify this. And so if I'm going to look at that and think about simplifying. What do I need to do then? Is I need to factor the bottom because the top is good. And I'm assuming that this guy has a 3x minus 2 in it. Let's see if that actually works. And that would make this a plus 6. And yes, it does. This is in fact the factor version of that. So we can now cancel this fellow with this fellow, leave one behind. And so the simplified version of our answer is x plus 6. What we're going to look at next is what do you do if the two fractions that you're trying to add do not share common denominator? And that makes these questions much more difficult. So let's start off with a simple situation and then progressively get a little bit more complicated. So suppose we had 4x plus 1, say over x squared. And we wanted to add it to 3x plus 2 over x. Now the denominator of this fraction is x squared and the denominator of this fraction is x. So what we need to do is we need to change this fraction so that it also has a denominator of x. And the only way that we can do this, and without altering the real value of the function, is to multiply by a special version of 1. And the version of 1 I'm going to choose is x. And so x over x is 1. Now what that is, it gives me this guy over x squared plus these two guys, which I'm just going to write down like this, over x squared. So what I now have are two fractions, but since they share the common denominator, x squared, I can do that. So what we have now is 4x add 1 plus distribute 3x squared plus 2x. Combine the like terms. And we're finished. So there's really nothing else to be done in that case. So let's look at a more complicated version of that same situation. This time we're going to have three fractions. And this is the version of question 2. So we're going to have 5 over 6ab, take away 5 over 12a squared b, plus 7 over 18a b squared. Now, each one of these is different, and so we have to basically get what's called the lowest common multiple. That's going to be what each of them change into. So I'm looking at this one at 6, I'm looking at this as 12, and I'm looking at this one as 18. So it's pretty clear to me that I can turn 6 into 18, but I cannot turn 12 into 18. So what I'm going to do is I'm going to turn them into 36. So all three of them are going to have 36. Now this is an a, this is an a squared, and this is an a. So I'm going to turn everybody into an a squared. And this is a b, this is a b, and this is a b squared. I'm going to turn everybody into a b squared. And so the LCM is that expression here. Now you look at your original fraction and you look at what this denominator needs to become. And that's going to tell me the special version of 1 that I'm going to have to use to make that happen. So 36, I have 6, I'm going to use 6 because that'll get me 36. I have a, but I want a squared, so I need an extra a. I have a b, but I want a b squared, so I need an extra b. So what I'm now going to do is multiply by this special version of 1, and the top guys get you 30ab. Now move on to this one now. The original fraction is 5 over 12a squared B. Now we just need to see what it needs to be changed into. Well, 12 needs to be changed into 3, so that means we're going to have to multiply that by 3 to get the 36. A squared is good, so I won't do anything about that. And I have a B, but I need a B squared, so to do that, I'm going to do that. So in this second fraction, 3B over 3B is going to do the job. So that's 15B. Now the last one, which is 7 over 18A B squared, which is this one. 18 needs to turn into 36, so 2 is going to do that. A needs to turn into A squared, so A is going to do that. It's already got B squared, so I don't need to worry about it. If you multiply these two together, you get 14A. Now we have combined all of them into a single fraction because they share a common denominator. And it's going to be 30AB take away 15B plus 14A. And that is it. I can't see anything very helpful or useful that we could do to make this one a little bit neater. So we'll call that one done. Right, moving on to question 3. We have 2y take away 3. And on the bottom, we have 5x y squared. And I'm going to add 4 take away 2x. And on the bottom, I'm going to have 10x squared y. And I need to turn both of these into sharing a common denominator. Right, I've got a 5 and a 10, so I can use 10 because 5 can become 10 if you multiply it by 2. In other words, 5 is in the 10 times, 5 times 2 is in the 10 times table. So I'm going to do that, and I'm going to have 10x squared y eventually. And y squared, in fact. X and x squared, I need an x squared. Y squared and y, I need a y squared. So I now know what to turn both these fractions into. These fractions have to be converted to that. So here's my original. 5 needs to become 10, so that means I'm going to have to do a 2 over 2. X has to become x squared, so we're going to have to do an x and an x. And it has a y squared, so I don't worry about that. If I take this term, Ten is okay, x squared is okay. The only thing that's missing is I need to add in an extra y. So multiply these out, and put the answer here. So I'm going to have 4xy take away 6x and 4y take away 2xy. And now I can combine them into a single fraction. And combining like terms, 4 of these take away 2 of those, leaves me with that guy, minus the 6x plus the 4y. And then I'll take out 2 as a common factor. And we get to cancel a little bit at least. Since I'm running short of room, the final answer is xy take away 3x plus 2y all over x squared, y squared. And that is the final answer, the most simplified version of these two fractions being added. So to finish this set of complicated fraction questions, we're now going to look at how do you simplify, it's not question 8, but question 4. How do you simplify this ugly fraction? And the trick is to multiply by a special version of 1. We're not going to add anything, we're just going to make these look pretty. Now, if I look at this fraction here, if I multiplied both sides by x, I would definitely get rid of this fraction, but I wouldn't get rid of this. So I'm going to up the ante and do this special version of 1. Now, x squared times that gets you x squared. X squared times that guy gets you plus x. X squared times 1 gets you x squared, and x squared times that guy gets you -1, and we're finished. So our next question will be similar to question 5. We have this fraction that we're going to try and simplify. Well, the only one that's causing trouble is this one, 9 over a. And so if I simply just multiply by that special version of 1, a times this gets me, well, actually, I don't even need to distribute it. I'll just write it down like that. And a times that gets me 9, and a times that gets me negative a squared. And that might be the answer, but I'm going to see if I can do better. Well, if you look at this, it's actually a difference of 2 squares. It's those two guys. So I can cancel this one with this one. And remember, when you have a minus b, b minus a situation, it just makes your answer equal. So we have negative a over 3 plus a, and that is the end of that one. And we are finished. So although it's only a short section, it is some really, really complicated fractions. So hopefully this will give you some help in how to do all 5 of them. And goodbye for now.